Yeah, Eric, I've actually been with the company for 16 years. But been using Thermal Desktop and various other tools for many more years than that. All right, so we're going to get started talking about improving graphic speed, uh, going over some Thermal Desktop settings and some AutoCAD options that you can take advantage of. Uh, the problem is models are just becoming extremely large. I created this little model here, this nice little gem. It's got 26,000 nodes, 85,000 solid elements. Uh, and really, the first thing when I see a model like this, I ask the question, is it really necessary? Now, I'm not going to go through all of these, but I do want to bring them to people's attention. So this is going to be more focused on just the settings. But when you do ask what is necessary, remove any unnecessary details. Here I left in a little seam that's at the groove that's at the seam between these two halves, which you can see increases the mesh density in that area, probably to no benefit for the thermal model. Um, very small rounds usually don't affect the thermal solution. Small features. It depends on your requirements. If you need to include them, include them. If you don't, it's best to leave them out. You could also model something as either a thin shell or sweep through, do a swept mesh through the thin bodies. Uh, this improves the meshing and also the solution as well. Uh, Using curved elements when you've got a high node resolution, node count, usually unnecessary. Curved elements increase the graphics load, they increase the computational load. Uh, the reason we have curved elements is that you can go to a coarser mesh, so you have fewer nodes in your thermal solution, but you're still capturing curvature, volume, surface area, things like that. Um, so it's best to kind of look at what you really need in your model. For general trends, early estimates, maybe a sphere is close enough. I mean, you might not need this kind of detail, in your first trade studies. Certainly, as you start getting towards CDR, or maybe even PDR, you're increasing the resolution and the fidelity of the model. But to start, why wait for CAD geometry when you can just create a very simple uh, model in Thermal Desktop? One thing that somebody asked me to add into this was exclude any unnecessary CAD geometry from the thermal model DWG file. Uh, we have ways you can use external references so you can see the CAD geometry with the thermal model, but then exclude it when you don't need it. Some of the slowest models we get are ones that have very detailed CAD geometry in there that's completely unnecessary for the thermal solution. Now, pipe center lines, parts that are meshed with the TD mesher, those definitely need to be included, but anything else is just load on your graphic system. All right, so let's get on to the main topic here, the graphic settings. Uh, in user preferences, you can change global visibility, which turns off all objects of a given type. So some of the ones I've used in this test, and I'll show you my test results in a little bit. TDRC nodes, which are any nodes that are defined by surfaces and solids. These don't include your boundary nodes or anything you've taken control of. Oops. Solid finite elements, uh, turn them off. Typically, you have a surface mesh on top of those. So drawing those in addition to that surface mesh is just extraneous. You don't have to do it. Um, Mesh importers and displayers. So in the ribbon, we have a few of these buttons that are available very quickly. If it's yellow, it's on. If it's gray, it's off. If it's faded, those types of objects aren't even in the model. If you don't see your option here, click the little arrow down here at the bottom of the panel, and you'll open the Preferences panel, and you'll go to Global Visibility options. There you can find mesh importers and displayers. You can turn those off. And TD Direct importers, we've added those to the global visibility as well. Layer visibility. Freezing layers is the best way to turn off layer visibility. AutoCAD tries to keep off layers that are turned off up to date, but then frozen layers, when you thaw them, then they're refreshed and updated. So there is a benefit graphically between turning layers on and off versus freezing and thawing. And we recommend using freezing and thawing. When you mesh with TD Direct or TD Mesher, we use layers to organize the parts of the mesh. There will be one labeled 2D, which contains any surface elements and the associated nodes. There's one labeled 3D, which contains all solid elements and associated nodes associated with the solid elements that aren't already on the 2D layer. There's an MC layer that contains the mesh controller. And then there's a PRT layer, which contains the part itself. Typically, you'll have this with the TD Mesher. I recommend when you're using TD Direct, don't even bring over the geometry unless you need it for other purposes. Each mesher or mesh importer has its own set of layers. And so you can use the layer manager to control layers of each mesher or importer individually, or you can use the mesher commands to control layers of all meshers or importers. And just to show you what that looks like, let me bring up, oh, this model will work. So under the layer manager, we'll have these layers here. And then we have our mesher commands. You can see only the preview, only the surface elements, only the solid elements. Turn everything on, turn everything off, toggle on and off of each individual. So this actually goes through and changes all the layers associated with meshers and does the same thing as if you open up the layer manager and froze each individual layer. Now, I did a time study. We have a tool that will go through and it'll basically invalidate all graphical objects and then rebuild them. And so I'm using this to compare the speed of various things. So what we're looking at is these are the objects that I've turned off or the layers that I've frozen. And I've normalized all to the original time. You'll see some slight variations, and that's simply the current GPU or CPU loads at the time that I measured it. So every time you run this, it might be slightly different. But if I turn everything on, so I've got the nodes showing, I've got the mesh solid and surface mesh displayed, I've got the mesh importer, the mesh displayer, TD Direct importer, all of those things are on. That's what I compared as my baseline. When I turn off nodes, I get an improvement. Mesh displayer, really no improvement. It says it went up, but I'm going to say that's in the noise. TD importer, again, pretty much in the noise. And the mesh controller layer, not much difference. Where I get a big benefit is turning off solid elements, whether I'm turning them off through global visibility or through the 3D layer. So that's drawing all the interior edges and faces of these solid elements that you can't even see because they're behind the surface mesh. So that would be the first thing I do is always just turn off solid elements. And that's this button I showed right here. Just click that, turn them off when you're viewing a mesh. If I turn everything off except for the surface elements, I get just a slight improvement on top of that. All right, looking at visual style edges. So drawing element edges takes time. Uh, and if you look at this model here, let's see, there we go. I've got edges turned on. Sometimes you want to see that so you can get a feel for the resolution, but other times it's just extraneous. And I'll jump back into this to show you um, how we do this. So we've added a command in the toolbar. AutoCAD has the command VS edges, and you simply set it to 0 to turn off all edges. We have this little icon in the toolbar with a little red X that goes along with all the visual styles. So this turns them off temporarily. When I reapply one of these visual styles, then the edges come back. But that could be the way you want to work. It can be applied to any of the shaded visual styles that shows edges. And then when visual styles are reapplied, as I said, whether you're refreshing your post-processing or you select it here in the toolbar, the edges will return. If you want it to be a little more permanent, you can actually edit the visual style itself. So use the Visual Style Manager. You simply type VSM, and then under the edge settings, you'll choose None for Show. And you can edit any visual style, including thermal and thermal PP. So that's the post-processing display. So if you never want to see edges, go ahead and make that change. So this is what that model would look like without edges. So you can certainly see what it looks like. You just don't see the resolution of the mesh. So if we take a look at this, just moving around, there's a little bit of hesitation there. And then if I turn off the edges, it will work a little bit smoother. Now, changing visual style edges and turning them off, I get a little bit of benefit on every single one of these. So you can see that that gives you yet another level of improvement. Now for the really fun stuff. AutoCAD has updated their graphics in 2023. They've improved some of their built-in visual styles to take advantage of modern GPUs and multi-core CPUs to offer smooth navigation experience for much larger drawings. They have two visual styles that use this. One is called shaded, and the other is shaded with edges. It only works in the model view, so post-processing viewports can't take advantage of the new graphics system. So, thermal PP visual style will follow the same behavior as the thermal on the slides I just showed. So certainly take advantage of those settings. AutoCAD 2023 is compatible with Thermal Desktop 6.2 and 6.3. And in user preferences for version 6.3, we've given you the option to choose shaded or shaded with edges if you select thermal in the Thermal Desktop toolbar. And then you also have an option to set shaded and shaded with edges similar to thermal. You'll notice if I show this, it gets a little shine to it because they're wanting a little more photorealistic type of view. This has a major impact. In fact, we actually found that we probably have a lower limit on our measurements for time. So comparing to the original, I'm just showing nothing off or everything except surface is off. The new visual styles are all down at the same uh, limit. Um, so again, that's probably something in the way we're measuring. We have a minimum measurement we can do, but it just really improves the behavior as you're moving things around. Takes a little bit for it to load in, but that's just a one-time deal, and then it improves. So just while we're doing this, if I switch to shaded, and so I'll let that, there we go. So that's come back. And so these little edges or facets aren't, we don't have to use those for radiation calculations. But it's just the way it's working in here. These are curved elements, so you can actually get down to uh, exact calculations if you need to. All right, few recommendations. Turn off the global visibility of objects that you aren't currently working with. And that includes nodes, heaters and heat loads, conductors, contactors, ties, anything like that. Once you've set up your heat loads or taken a snapshot of what they look like or where they're applied, turn them off. That was in that earlier ribbon up here. You'll see heat loads here, you'll see conductors, you'll see contactors. All of these are just very easy to click on and off. So turning on nodes kind of gives you a show, and I think it actually has to reload. So let's switch back to thermal. Yeah, see, I don't need to see all these things unless I'm actually selecting something. And we're going to talk about a tip later uh, that avoids having to select individual nodes. If you're viewing an entire finite element model, uh, turn off all objects except the mesh displayer. The mesh displayer can actually be shown with shaded exterior faces, and it's a single object to be drawn. So it's much quicker response time than showing all the individual elements. Going back to our original normalized time using thermal visual style, redraw normalized time is 0.21. So 20% of the original up refresh time. If you're viewing a portion of a finite element model and you need to see the solid elements, you can turn off all objects except for solid elements and then hide the interior faces. We have a command. Let me switch over to here. It's right up here under modeling, hide interior faces or show solid interior faces. So this, I'm pretty certain, has been hidden. Takes a little bit to get started, but then it picks up speed. And if you are hiding a portion of that model, I would recommend hiding it before you hide the interior faces. Just doesn't get quite updated the right way. So turn on interior faces, hide everything, then hide your interior faces. For this, the thermal redraw normalized time is 0.24. So you get a pretty decent update with that, even though you're showing solid elements. All right. Hope everybody liked that and everybody's still on and not going out and updating their AutoCAD right away. Uh, anyway, I'm going to move on to right-click tricks. Right-clicking when you click the right mouse button, it can perform certain behaviors. Those behaviors will change based on what you have selected, which window is active, and often opens up a context menu. And a lot of these tricks that we're showing are actually within those context menus. We do have a video on right-click tricks already. You can go to our training videos website. You do have to be logged in as a registered user. And then just search on right-click for your keywords, or you can scan the QR code. This video covers these options. I'm not going to go through all of them, but things like case set override reviews, viewing contactors graphically, the active faces graphically, and things like that. I'm going to add to that list in the next slide. So a few additional tricks. In the model browser output frame, you can change the tree frame background color. And I'm going to close out some of these models here. And then open up my other ones here. Okay, so in here, if I right click in the tree frame, you can change the background color. Some people were complaining they had a nice dark office, I guess, and they have everything fairly dark, and then there's this bright white uh, uh, model browser. So I can switch it to black, and so that kind of provides you a little less bright white on your screen. Zooming a selected object. This is really useful when you get a very complex model. Let's say I want to find the pump in this model. If I right click, you'll see there's quite a few options down here. Zoom selected objects. Come in, there's my pump. It's right in the middle. So this is a great way to find those little detailed parts, those parts that are causing problems in your solution. So you can find them, make sure you're getting the right one, and then edit it. Showing analysis group for selected radiation surfaces. If I come back in here, list by surfaces and solids. Now down here, you can see we have a summary of the objects I've selected. What we've added is the ability to right click on that, and let me see if it's in here somewhere. I usually find these things pretty quickly. Let's see. Oh, sorry, it's in the output. So I go to the output and show analysis group for selected radiation surfaces. Now, if I select specific surfaces, you'll see analysis group. This is in base and lower, and this one is in base and upper. That gives me a little bit more information in that output field. And then toggling enabled status if it's not controlled by an expression. So we have ways of turning objects on and off for solutions. It's called enable disable. And if I come in here and I'll just pick what I do. Here we go. We've got some conductors. So I want to turn off the upper conductor here. And if I could open this, edit it, and then switch enabled to a value of 0, and then it's disabled. However, uh, that takes a lot of jumping around. So what I can do is I can right click on it and then I can toggle the enabled status. And so now it is disabled. And so the next time I run the solution, that conductor will not be included in the solution at all. Now, if you set this up with expressions, we recognize that. We're not going to change it if it's controlled by an expression. You're going to use your expressions to actually change that. In the case set manager, one of the earlier ones we showed was being able to see the overrides in the model itself. But now we've actually added in the ability to view your case set comments. So if I open my case set and I right click on a case set, you can see this solution stops when TL 999 is greater than or equal to a temperature limit, and the last output time is the time. So I've written this in the comments of the case set, and I can see what those comments are right here. And then object lists that you see in conductors, contactors, and things like that, you can actually search the list for a text string. I don't have a model that's complex enough that requires that. But if I look at my conductors and I see a list here, this list could go off the page. I don't want to have to scroll to find something. I can right click and then search and select the first object found. Or I could search and select all, and then I can do a display only, or anything else like that that gives me an opportunity to review what that is. And again, this is something I should point out. If you add in a comment to your plates, that comment will be in here and it will be available as a search field. That works for this, and it works for the model browser itself. All right. So those are the tricks that I had for that one. Let me close this out. Open up my next model. So plotting node, path, or tie data along a pipe. I had somebody ask about this the other day. They wanted to use the XY pipe plot, but they wanted to plot heat transfer coefficient or something like that, or maybe pipe wall temperature as a function of the distance along the pipe. The XY pipe tool only plots lump values as a function of the distance along the pipe. So you select that command, then you select your pipe, and then you get a plot like this. So how do you plot another value? So this is going to get it pretty deep. We have some videos that will cover these tools in depth, but I just want to show that it isn't that difficult once you understand these tools. So network element logic makes writing logic much easier for your model. You don't have to know specific IDs for network elements. We have a video that covers network element logic, so I'm not going to go into the details here. UDFAs, or user-defined Fortran arrays, can be sized to network elements such as nodes, lumps, paths, conductors, and their values become additional variables for those objects. So you can post-process them just as you do any other variable. So we're going to put these things together to create a lump variable for, say, heat transfer coefficient. If you would need to learn more about logic and advanced logic usage, we do have a video for that as well. We recommend that you watch the network element logic video first before watching the advanced logic. So the procedure, in the logic manager, you're going to create a lumped sized UDFA. So that'll look like this. We have AHT, which is heat transfer area sum. We have the heat transfer coefficient times area sum. And then we have the average heat transfer coefficient. You can pick which of these are actually stored in the results file. For this, I'm only post-processing heat transfer coefficient average, so I only have to have that one in the results. You're going to add logic to flogic 0, which is time dependent. What this does is it sets the entire arrays to 0. Then I'm going to add logic to the output calls before all submodels. And what this does is it looks at any place that the heat transfer area is 0, is not equal to 0, it's greater than 0. Then I'm going to set my average heat transfer coefficient to the UA sum divided by the AHT sum. And what I'm doing is I'm working with the entire array here. So I'm not looping through every element in my code. The compiler understands that and is going to set it up for me. Then I'm going to edit the pipe and add pipe level tie logic. So this applies to all ties within that pipe. And ties are essentially your convection from the fluid to the wall of the pipe. And I'm going to add logic to the flogic 2, which is solution dependent. So it's at the end of the time step. And you'll notice that this has these hash symbols in here so you can, it references whatever lump is associated with this particular tie. So I don't have to know these numbers. We fill these in for you when we generate the sendif file. So if I go back into my model here, if I look at the logic manager, here you can see where I've created these arrays. And I just edit one of these. This one is not saved to the results. This one is. And then I have my logic that I'm going to add in. And this is the same as what I showed on those slides. And I'm only looking at this one pipe here. So I'm going to edit that pipe. And you can see we have lump logic, path logic, tie logic, node logic. So under tie logic, I can go in here. And you don't have to remember all of these formats. If you right click, get another right click trick. If you've got UDFAs, we have ways of referencing those. And network element logic available operators, you can add those in as well. So we update this depending on where you are in this in the model. And so it helps you not have to remember all the little shortcuts. Now, when you're done with your solution and you're going to post-process your UDFAs, you can select them, any UDFAs that are saved with the results and are sized for an object as a variable of that object. So when I'm editing my data set, if I have a UDFA that's sized for lumps, I can pick that as the variable for the lump and post-process those values. And so then I can look at The heat transfer coefficient is a function of distance. You'll notice this drop off here. The end lumps on pipes aren't used with ties, so HTC is set to 0, uh, simply because the area is set to 0. If I display my results, and I go to edit my current data set, choose lumps, and all the way down here at the bottom, you'll see HTC average, and then OK. And if I cycle my color bars and get to lumps, you'll see here's the HTC. And if I want to plot along a pipe, pick my pipe, and oh, I didn't pick the pipe. There we go. So I would have to come in here just to get a look at it. Let's see, this is between 34 and 36. I can customize. And for my axis, set min and max. And so I can get a better feel for where that is. All right, and I've got time to go into my last one, looking at temperature measures. So temperature measures are intended to read the temperature of a location in a model regardless of node placement, just as a thermocouple or a thermistor would do in a real system. So it maps to a surface and will interpolate the temperature to that location, whether there's a node there or not. Creating measures, you can either create single measures one at a time, or you can import measures from a file. For the single objects, you select the location, set the size and options. If you're importing from a file, all the settings will be in that file. That file format is documented in our manual if you need to see that. Then you update your measures. That will force them to map to the surfaces. By default, it'll go to the closest surface. You will see crosshairs that indicate the mapped location, and a circle will indicate that you're mapping to insulation, which is one of your options. So this one is going to insulation. This was going to the underlying surface, the substrate. You can check your summary files in the map data folder to look to see what you mapped to, make sure it was the right surface. You can also rotate these for visibility purposes. And if you find that you map to the wrong face, like you meant to map to the top face and it mapped to the bottom face, you can offset the measure slightly in the direction of that face and then update again, and it'll map down to that surface. If it maps to the wrong object, you can use groups or domains to limit the available objects for mapping. So if you've got several objects that are really close together, it may be easier just to put things into a group or a domain and map only to that. Now, how do measures behave? In the measure edit form, and while I'm talking about this, I will switch to my next model. There's the Cinda interface options. If you choose, oh, here we go. So these are measures that I've set up. They have a size, so you can make them bigger or smaller depending on what you want to do. Uh, I would say acknowledge that they're going to be bigger than you think. So start pretty small. You can always, if you can't find it, you can find it in the model browser. But this is what the form looks like. And here's the testing to a domain or a group, which I don't have set up. Here's the option to connect to the outermost node of insulation if it's found on a surface. So all of those options are in here. Uh, choosing output register uh, will generate a register and and it will update the temperature or the value of that register with the temperature during the solution. You can actually create a node from a measure. And if you check, or if you leave use conductor and thermal capacitance unchecked, you'll get a boundary node with the temperature updated during the solution. It will not be connected to the model, so it's not going to drive temperatures in your model. It's just updating with an expression. Uh, if you do check use conductor and thermal capacitance, you'll get a node that's connected to the thermal model, and it will be part of the thermal solution. If you set the thermal capacitance greater than 0, you'll have a diffusion node, and it will actually slow your response time down. If you set it to 0, it will come in as an arithmetic node that simply remains in a steady state condition. If you don't check either of them, then the measures are simply used for post-processing, and they will show the interpolated temperature while you're post-processing. Okay, when you are post-processing, the measure ID shows the interpolated temperature. The node ID shows the node temperature. Typically, those are the same, but if you have a significant capacitance and a low conductor, then they can be significantly different. So be aware of that as you're going through. So if I jump back into my model and I wanted to create a measure, we have a measure panel over here on Thermal 2 tab. We have a menu that's just for measures. There's create, which is create a single one, and I can pick a location. I know what size works pretty well here. And then here are my options. Send interface. If I leave it all unchecked, this is just in Thermal Desktop. Say OK. Now you'll see it's set up along the Z-axis. I can do a rotate 3D. I pick my object, 2 points for an axis, and rotate 90. Now I don't have a crosshair yet, which means I need to update. So over here, update, and then I see my crosshair show up. And this is going to measure the underlying surface temperature, not the insulation, because I didn't check that option. All right, let's see what this looks like in post-processing. So if we look here, you'll notice this one is actually warmer than the surface underneath. And this is actually showing the surface because I'm displaying my insulation temperatures here. So this matches the color contours on the insulation, but this is reading the temperature underneath. So I see that temperature. Same thing goes over here. And then this one, I've actually set this one up as a conductor, and we're going to have some fun with that one. So some recommended uses. The original intent of measures was for test data correlation. Thermocouples are almost never located where a node exists in your model. Measures will improve the correlation because you should be better matched with the thermocouple location itself. Use them for heater logic or logic control, or heater control or logic control. You can use a measure as a heater sensor and place it where the thermistor is located, or wherever the heater control is actually located in the model. It doesn't have to be the same as the heated object. If you're doing optimization, a node's location can change if a surface's size changes. If you're trying to drive to a temperature at a particular location, then you want the measure to stay in that place. So a measure will stay in place unless it's attached to an assembly and the assembly is moved. Thermal connections. Connecting to a measures node is going to be better than connecting to a specific node on a surface. I see this happen often. When you change the resolution of the surface, it kind of breaks things because the node is deleted and then recreated as part of the surface, but then it's also part of this conductor or conductor usually. And so it gets maintained for that. So it becomes its own entity. So you have to be very careful if you connect directly to the node of an object. A measure is going to be more accurate than, say, a contactor for a small object on a coarsely subdivided surface. Let's look at this model again. Over here, I'm going to switch to substrate temperatures. So you can see, and I'm showing the measure temperature and the actual node temperature. This is an arithmetic node, so it really doesn't change. It has no heat on it, so there's no delta T across it. But you see it does match up with the color contours here, both the node and the measure itself. If I switch to, I'm going to freeze my measures layer. Let's see. Because it's the current layer. Freeze measures and turn on my object. I've created this little surface that has zero capacitance, has the same conductance to the surface, but it's much hotter than that surface. And why is that? Well, if I look at my conductor or contactor markers, sorry, I can't get used to this. If I look at my contactor markers, you can see why it's so much hotter. And if I right click here, show contactor markers, it's only connected to this node up here in the corner, because the way I've modeled this is just 4 nodes on the surfaces. The contactor finds the closest node or nodes and connects to them. Now, if this had been in the middle, I probably would have had a much closer result. If my resolution had been a little higher on the surface, I would have had a closer result. But in this situation, I have a very coarse model. I've got a very small part that's connecting somewhere to it. In this situation, a measure actually works better. And I could have them set up even a surface here. I can use a clone node to tie it to the measures node, so you can have that combination of best of both worlds. All right, so we'll be able to move on to questions. If the questions come to you later, you can always email, or if I don't get around to your question, you can email support@crtech.com and we will certainly get back to you. Make sure you note that it's from the TFAWS tips and tricks presentation, and then it'll get routed to me. Um, and then I recommend you register for our website so you can watch training videos and find additional tips. If you get to our website, you'll see customer login, select that, and then uh, under the login, you'll click here to register, and we'll be able to sign you up, and you'll set up your own password. All right, let me.
Hey, Doug, great presentation. Thanks.
Thank you.
And yeah, and I do recommend you register for the log for their website. There's even downloads. There's been times where I've had a problem that I need to model, and lo and behold, there's an example there that I pulled out. That's model that's running. So that's great advice.
Okay, let me see.
Yeah, can you see the chat there, Doug? It'd probably be more
I
efficient
can.
to
Let me
share.
make sure I
The first one is will
yeah,
a
I think I passed
temperature
the thank
measure
yous.
work for a TMM developed in the Logic Manager?
Okay.
That's the first question.
Okay, so temperature measure is a graphical object, so it would not work for uh, text-based models in the Logic Manager. But if you do have surfaces associated with the nodes used for radiation, yes. So it's going to let's see. Actually, I'd have to test that out, and it'd be a pretty simple test to see if it works. But um, so you've probably got the nodes and conductors turned off. Yeah, that I should take back my answer there. That might be a little more complex than what I think. So let me uh, let me work on that. If you could send that uh, into support, we could get you a better answer after I have a chance to test it. All right. How many of the right-click tools you mentioned were added in 6.3 or our majority also in 6.2? Oh, good question. But I'm some of these I've discovered myself recently, so I don't know when they showed up. Uh, you'll just have to right click and see if it's available when you're in 6.2. Um, so I don't know the breakdown on that. Let's see. Can you easily export the measures temperatures to a file for transient solutions? Since if they're a node, they are part of the solution itself. Um, so you could also use, we have in post-processing, we have write results to text. Uh, and if I go in here, add results, add, and if I just type in TC, because I create all of my measures in the TC submodel, um, and I have to do dot star. So all nodes in the TC submodel can be written out, and I can do all of them to a single file. For each save file, I can set a start time and end time. And when I'm done with this, before it, I recommend switching to the CSV format. Um, XLS is simply an ASCII file. And so every time you open up the XLS file, it's going to say, oh, this isn't a true Excel format. You can get around that because CSVs are usually associated with Excel. So you write it as a CSV, it's comma separated. You double click on the file and it'll open up in Excel. Or you can use the data tab and actually associate to a text file. All right, back here. Oops. There we go. Um, okay, for the right. So this next question seems like an easy addition, and of course not a question, Hume. Uh, seems like an easy addition to include active side as well as when displaying radiation group for selected surfaces or maybe even top bottom optical properties. We'll look into that. Um, it can get complex if you've got solids, so it's not just as simple as top and bottom. But we'll take a look at that, Hume. Uh, let's see. Does AutoCAD 2023 share DWG format with 2018? It actually does. So AutoCAD 2018 format is the same for uh, all the way up through 2023. Um, so if you open up AutoCAD and look at the save as, um, it will only show 2018 as the version you're saving to. Uh, so yes, it's all shareable. Thanks, Hume. Uh, all right. It wouldn't be TFAWS if Hume didn't give us some suggestions.
Yeah, I think he
Um,
wants that changed to the code, Doug.
yeah. Sounds like I can make a conductor to measure, um, make a conductor to a measure that creates a node. Will a contactor also attach to a measure? Well, it's to a node. The measure is actually a node. So typically you're going to have a node to something conductor. Um, and what this is doing is it's taking the interpolated temperature and then calculating the delta T through the conductor. Um, so a contactor wouldn't necessarily work with a measure, um, but you can certainly connect other things to a measure. You can merge nodes. You can do things like that. So you do have to specify the conductance. So in SI units, that's watts per Kelvin, and you don't have a per area, but that's because that's measuring to a point, and that's what a measure does. So if you're getting into a contactor, you'd probably want to have a surface anyway. Um, so maybe I'm not understanding everything in your question there, so maybe an email to support would be able to clarify that.